Here we are on our fourth construction, and with this one we are trying to construct the perpendicular bisectors of a segment. So first off, when you think of perpendicular, you should think it's going to intersect at a right angle. So if I just draw a little line over here, you've seen that as this little right angle symbol. These two lines would be perpendicular. They intersect at a 90-degree angle. So this angle right here, actually all of these angles are right angles because perpendicular lines intersect, forming four right angles. When you think of bisector, you're cutting something in half. So what we are going to do is draw a line that's perpendicular to this line, and it's going to cut it right in half. So when we do this, we're not taking our ruler out and measuring. We're going to use our compass again, and it's going to be very similar to other constructions that we've done. You are going to figure out what is the midpoint basically of AB, and then draw a line that's perpendicular through it. So the first step when doing the perpendicular bisector is to pick a compass length that is over half the distance from A to B. So this right here is over halfway from A to B. So I'm going to stick with that, and I'm going to draw an arc above the line and an arc below the line. And the reason I'm doing this is I want to figure out where these arcs that I'm going to be drawing are going to intersect. So the distance from point A, where my foot is, or the center of my compass is going to be the same distance from here as it is from there. So those are the same distance from point A. Then you're going to go over to point B and do the same thing from point B. So starting at B, you're drawing arcs above and below. So notice my arcs are going to intersect at these 2 points. So I have an intersection of arcs here, and I have an intersection of arcs here. If you were to draw dotted lines here, we have just formed an isosceles triangle up here. This length is going to be the same as this because we did not change our compass length when we went from point A to point B. So same down here, we've got the exact same isosceles triangles, with the same base. So now what we can do is we can connect the 2 points, the 2 vertices of these isosceles triangles. So draw a line through the intersection of those arcs. This line right here is going to be the perpendicular bisector of this segment. So this segment right here is going to be congruent to this one. If we called this point right here M, that would be the midpoint. So this construction, doing the perpendicular bisector, isn't really all that involved. It should be pretty straightforward. You just pick some length on your compass, make an arc up here, an arc down there, use the same length of your compass starting at B, and do an arc on the other side. So let's do it again real quick. We're going to do it over here on CD. Notice we have a longer segment, so you're going to have to adjust your compass to make sure that your compass length is still over halfway. Draw an arc above, arc below, move over to D, do the same thing at D, arc above, arc below. Now you have 2 intersection points. Take your straight edge or your protractor, whatever you're doing, ruler, protractor, draw a straight line through those intersection points. Now we have another perpendicular bisector. This is going to be the midpoint of CD. So how would we end up using this, or why would we end up using this? Well, let's think, for instance, back to the first construction we had. We were copying line segments. So maybe you were told to draw a line segment that's the same length as AB. So we copied the length of AB and put it on another line. Or we did the example before, if you were watching that video. Let's say we wanted 2AB plus CD. So we did 2 lengths of AB plus the length of CD. Now let's say we want to do 2AB plus 1/2 of CD. So how would we do 2AB plus 1/2 CD? Well, let's start out with a straight line like we would normally. I may have to extend that. We'll find out here very shortly. If we want 2AB, this is going to be very similar to what we've done before. You're going to start with A, figure out what's the distance from A to B using your compass, not your ruler. So this is about the distance from A to B. I usually make a little arc again to show that it's going through B. Start here, your starting point, make an arc, strike an arc. That's 1AB. This is 2AB. And then it says we want to figure out what is 2AB plus 1/2 CD. Well, the thing that's nice about this right now is we've already cut CD in half. So it's going to make it relatively easy. If we were just given CD here, we know the length of CD. You'd probably think, okay, how do I find half of CD? Well, the way you find half of CD is by doing the perpendicular bisector, because the bisector cuts it in half. So we know that this distance right here, CM, is going to be the same as MD right over here. So if these two distances are the same, this is the midpoint, and this is half of CD. So take your compass, same thing as before, figure out the length between C and M, the midpoint of CD, and then all you're going to do is move that down here, add it to this segment down here. So from this point right here, call it X, to point Y over here, this is going to be the length AB. This also is going to be the length AB. This is going to be the length 1/2 CD. So the entire thing is 2AB, if we add it all together, plus 1/2 CD. So what we've done is we've constructed a new segment that has half of CD. Let's say we wanted 1/4 of CD. All you do is the perpendicular bisector, and then once you have half of it, if you do half of a half, that gives you 1/4. So you could do the perpendicular bisector again to get 1/4 or 1/8 or that type of thing. So that's what you'll end up using this type of thing for in the future. Just keep that in mind, and you'll end up being a little creative with that, hopefully.